Hey everybody, Mr. Judson here. So let's see, today we're talking about functions, which again I think is something that's fairly easy for us. I don't really think I'm going to teach you guys anything new today. It'll just be a review over some things that we've already seen. So let's start with this. Let's say that I've got a function, f of x, that is equal to x squared minus 3x. What I want you guys to do is to find f of 5 and f of negative 3. You guys go ahead and try that real quick. Alright, so we probably remember that this just means we're going to plug some number into this function. So I'm putting a 5 wherever I see an x. So this right here would be 5 squared minus 3 times 5. So 25 minus 15, and subtract those and we get 10 for an answer. Alright, so this one, if I'm going to plug a negative 3 into this, then what I'm going to get is a negative 3 squared minus 3 times negative 3. I want to be real careful how I write this, because if I would have just said negative 3 squared, what that means is I'm doing 3 times 3, that's 9, and then the negative of that answer. Okay? And that's not what we want to do. We want to plug a negative 3 in here and make sure we do a negative 3 times a negative 3. Okay? So, let me just go back and erase this. So a negative 3 squared would be a negative 3 times a negative 3, that's 9. Here I've got another negative 3 times a negative 3, so plus 9. And what I get for an answer is 18. Right? So using that same function, x squared minus 3x, let's see if we can find this. F of n plus 3. You guys go ahead and try that. Alright, so there's my function. I just copied it over because I can't see it anymore. I'm going to put in the expression n plus 3 in both of those spots where I see an x. So this is going to equal n plus 3 squared minus 3 times n plus 3. And we got to be real careful here. A lot of people look at this and they just go, oh yeah, n squared plus 9. And I bet some of you guys did it. That's pretty normal. But what I want to do is I want to do n plus 3 times itself. And when you multiply that, you got to FOIL the whole thing. So I'm going to get n squared plus 3n plus another 3n plus 9. And then up here, when I distribute that negative 3, I get negative 3n minus 9. So, a lot of times people will use a shortcut for this. And the shortcut is you square the first term. That's what happens right here. Then you multiply the 2 and double it because it's going to happen twice, and then you square the last term. I'm going to use that shortcut a lot. That's one of those things that probably you guys should have talked about in Algebra 3-4. But if you don't like the shortcut, if it causes you to make mistakes, write it down twice and FOIL it. Do what guarantees getting the right answer. Okay? Now I just want to add up like terms, and what I see is that those two add up to 0. Those two add up to 0. And so there's my answer right there. N squared plus 3n. Alright, it's going to get a little more complicated. Remember, I told you guys one of the things that we do in PreCalc is we push everything a little bit farther. Okay? So this time I want for you guys to find f of x plus delta x. And you're thinking, delta what? So delta x is something that we use in calculus that represents a very small number, okay? Very small, 0.00001. And so it's a variable by itself. It's not a triangle times x. It's just delta x, okay? And even though I have two things written there, I want to think of that as one single variable. All right, we're still plugging this into f of x equals x squared minus 3x. You guys go ahead and try it. All right, so I'm going to plug an x plus delta x in place of each x here. So that means I've got x plus delta x squared minus 3 times x plus delta x. So it's a triangle. And I want to simplify that. All right? So I'm going to use that shortcut this time. You square the first term, multiply the 2 and double it. So if I multiply these, I'm going to get x times delta x. It's not triangle x squared because this variable isn't the same as this variable. It's kind of like if you're doing x times y, it would be just xy. So multiply those, we get x delta x, double it, we get 2 of them. And you square the last term. So remember, if you don't like the shortcut, just write this down twice. Do what exponents mean. It means take this times itself, and so write it down twice and work the whole thing out. Minus 3x minus 3 delta x. And so when I look at that, there really aren't any like terms, so there's nothing else we can do with this problem. At this point, we're done, and we have answered that question. All right, I'm going to give you another one here, though, that's even uglier than that, and there is going to be some stuff we can do at the end. So let's try this one. This time, f of x equals 2x squared plus x minus 4. And what we want to do is we want to find f of x plus delta x minus f of x, and then divide that whole thing by delta x. You're like, what? Come on, Judson. Yeah, this actually becomes a really important concept to us in calculus next year. And so, you know, one of the things that we're really starting to see in pre-calc is this problem showing up more and more, so that when we do see it next year in calculus, we're kind of like, oh yeah, I remember that. No big deal. All right? So, when I look at this, what I'm seeing is I plug this in first, wherever I see an x. Here you're putting an x in place of x, so it should look the same, and then divided by delta x. We're not plugging this in because it doesn't say f of delta x. Okay? Let you guys give it a shot. All right, so I'm going to take this right here, plug it in wherever I see an x. So I've got 2 times x plus delta x squared plus x plus delta x minus 4. So far I've only done this. I haven't done anything else. This says minus f of x, which means I need to subtract what f of x is equal to. So minus 2x squared plus x minus 4. Divide the whole thing by delta x. So now what I have is this kind of messy algebraic expression that I need to simplify. And anytime you guys hear me say the word simplify, to me that means do as much adding, subtracting, multiplying, and dividing as possible. Do as much as you can. Okay? All right, so, well, first of all, I'm going to go ahead and multiply this thing out. So I'm going to square the first term, multiply the 2 and double it, square the last term. And I still have to multiply everything by 2. Plus x plus delta x, we're not multiplying by anything, minus 4. Here this negative sign has to be distributed to all 3 of these terms. So a negative 2x squared minus x plus 4. Divide all that by delta x. So I'm gonna just so I don't have to copy the whole thing over, I'm just gonna real quick right here say, if I distribute a 2, this is gonna be 2x squared plus 4x delta x plus 2 delta x squared. And I'm just doing that because now I can add like terms together without having to copy the whole thing over. So let's see, I've got a positive 2x squared here and a negative 2x squared there. I see a negative 4 and a positive 4. And here I see a positive x and a negative x. So I was able to cancel out quite a few things. Right? Opposites add up to 0, and 0 plus anything is the same thing. So what I'm left with is 4x delta x plus 2 delta x squared plus delta x. Still dividing by delta x. Well, that got a little bit neater. So now what I notice is there's a delta x in all 3 of these terms, which means I can factor one of those out. Right? Remember, factor means divide out. If I have the number 10, its factors are 5 and 2. So if I take 10, I divide it by 5, I'm left with a 2. So I want to divide a delta x out of each of those when I factor it. So if I take that out, I'm left with 4x. Take one of these away, I still have one left. And take that away, I'm left with 1. Not 0. Because remember, when I distribute this back, I got to end up with the same thing up here. So delta x times 1 would give me that delta x term. So now if you take an expression and you multiply it by something and then turn right around and divide it by that, you come right back to the same thing. So we could just say that that divided by that is 1, therefore it cancels. And so now my final answer is 4x plus 2 delta x plus 1. Huge idea next year in calculus. Huge idea. Even the calculus class doesn't know yet how big this idea is to them, but they're going to know soon. They're going to know soon. Okay. Let's say I've got a function like this. So this is now number 3. F of x equals the square root of 2x minus 1. And I want to find f of 5 and f of, let's go f of 14. Okay, let's go ahead and find those two answers. So just as a reminder, you're always hitting your pause button. If you think, oh, Justin's going so fast, you guys are in control of that. You can hit the pause and slow things down. I need to go kind of fast because when I do a video, it takes up a lot of memory, and just trying to navigate everything, it makes it a little harder. So really important you hit that pause button every time I tell you guys to try something. All right, so if I plug a 5 in here, I'm going to get the square root of 10 minus 1, and that's going to be the square root of 9, which is 3. If I plug a 14 into here, I'm going to get the square root of 28 minus 1, which is the square root of 27. And it's not a perfect square. But one thing that we have to make sure we do is we want to make sure we always simplify square roots. So if I think of this as 3 times 9, and 9 would break down into 3 times 3, anytime you get a pair of factors the same, if you multiply those you get 9, the square root of 9 is 3, so when you see a pair of factors it means you can bring one of them to the outside. So 3 root 3. There's my simplified answer for that one. All right? All right, we got one more thing to look at. All right, so what I have here is what's called a piecewise function. Okay? And what a piecewise function means is f of x is going to be equal to one of these pieces. And we're not just limited to 2. I mean, I could have 3, 4, 5 different functions here. And so a function has pieces, and you only plug a number into one piece. You would never plug it into both, or all 3 if there was more pieces. Okay? And the way you decide which piece you're going to use is based on the x value that you're plugging in, and is it less than 4 or is it greater than or equal to 4? That's how we decide. Okay? This comma doesn't mean anything other than I'm using this piece when x is less than 4, so comma. I'm using this piece, comma, when x is greater than or equal to 4. So if I ask you guys a question like this, let's find f of -2 and f of 5. You guys go ahead and answer those real quick. I would look at this and I'd say, okay, -2, that's the number I'm plugging in. It happens to be less than 4, so I need to go into this first piece. So this is going to equal a -2 squared plus 2. I don't want to plug it into this piece because -2 is not greater than 4. Right? So square this, you get 4 plus 2. My answer is 6. So when I look at this, I would say, okay, 5 is greater than 4, so now it needs to go into the second piece. And so what I have is 3 times 5 squared minus 1. So that would be 25 times 3, that's 75 minus 1. My answer is 74. What if it said, find f of 4? Which one do you plug it into? First or second piece, or both? Well, according to this, 4 is not less than 4. I'd get a false statement here, so I don't want to use the first piece. 4 is greater than or equal to 4, so this is the one you would use when it's equal to both of these. It's pretty rare that you would have a piecewise function where maybe this is x is less than 2, and here x is greater than or equal to 4. So what's f of 3? Well, 3 doesn't meet either one of those conditions. I suppose that could happen. We would just have to say it's undefined. We don't have a piece to plug in numbers between 2 and 4. Okay? All right. Okay, that's what we have for today, so let me get you guys a homework assignment. All right, so this does not look like a very long assignment. We've got number 3 continued, page 49. So remember, we got all of assignment 3 is due next Wednesday, right? Page 49, I got 25, 28, 30, 36, 37, 81, and 83. And I'll go ahead and give you guys these answers to the even ones next week when we meet. I'm not as nice as I look. You'll find when you turn to this page in the book, there's going to be like a part A, B, C, A, B, C, A, B, C, D, E, F, G. I don't know how far it goes, but yeah, it's a little bit longer than it looks. But this isn't really that bad. I mean, these kind of problems are fairly easy, so we should be able to zip through this pretty quick. All right, so that's what we have for today. Hopefully we'll see you guys next week. Depends how that surgery goes, but you guys take care. And remember, if I'm not starting up a Teams meeting on Monday and Tuesday, just go ahead and go right to where the videos are, and you guys watch it. I'll teach all this stuff, and then you can go ahead and start with the homework. All right, there we go. You guys have a good day. Take care.